Hey, everybody. So, if we're going to talk volcanoes, we're obviously going to have to talk about igneous rocks and lava a little bit. So, I wanted to just do a quick run through some of the important stuff from the chapter in that online textbook, if you saw that I had attached as part of the assignments. Which you can find, I believe it was 6. Nope, 7, chapter 7. So, go to that. And let's think about what's going on. Now, it may be tempting if you're like a rookie in geology to say that, all right, I'm kind of getting down what this Earth is, that we got this thin outer crust like an M&M or like proportionally like an apple, a very thin outer crust, and then inside is this goo, and occasionally it comes out, and that's what a volcano is. And if you're in that mindset, the problem is that all of that stuff that's coming out, that goo, would be exactly the same, right? But it's not. There's big differences in the compositions of that magma. So we're going to call it magma below the surface, lava on the surface. And then we got to wrap our heads around the idea that that might be made of different minerals. It's not all the same stuff based on different tectonic settings. And maybe we'll get into that a bit, but let's just say today, like kind of throw out the endpoints of what's there. Because it's a continuum, and it's not just that, okay, there's different types. That means there's this kind and this kind. There's really like a continuum of the different minerals that might be in that magma that then we put into categories that we've invented to say that's more of a felsic magma down to that's more of a mafic magma. Those are the more common, and yes, you can get to the ultramafics as well. And we're also going to have to think about, and I don't think I want to go too hard on it in this video because it could be part of what we'll do next. Why melts? That's going to be one of the things we got to consider in this course section. Because, hey, we talked about seismic waves going through this area, right? We talked about seismic waves working its way through the crust, and that's how we've delineated what's going on through all these different layers, including the idea that if you get to a liquid like in the outer core, that it stops. So if today you say, like at some point this might occur to you, if you say, well, if I go and see a volcano and I see it coming out, that is a liquid, right? You can see it coming out in Hawaii all the time. It's clearly behaving as a liquid. And you could say, well, hey, buddy, you told me that down here, the outer core is the only part that's really a liquid. And there's clearly quite a giant section here between that. So how does this area both transmit S waves, indicating it's a solid, and have a liquid state where it's coming out of volcanoes? So that's a great question. If you can get to that, you're really thinking through this. So what you got to consider, or what we'll have to consider moving forward, is what are the little environments within this mostly solid, and granted it can be like an amorphous solid, like a thick Play-Doh, but what are the like little micro environments where it can transfer over to a liquid, which will be that's when we can say that we've got like eruptible magma, lava that can come out onto the surface. Because mostly it's a solid. So what's the deal here? That contradiction, if that occurred to you, good job, and that is where we're going. And now within that, what is the stuff made of? Because what this is going to lead to is different types of volcanoes. So if I just chuck that at you to say, hey, there's these volcanoes and there's these volcanoes, the root of that is understanding a little bit about igneous rocks to say that there are different compositions of magma within the planet. And it's because of what's like, where is it coming from within the mantle there? Where is it like interacting with the crust that can add and subtract different minerals? In fact, if you want to really complicate your life, look up the Bowen's reaction series thing. And if you say this looks like a step too much, we'll take it easy on this and say that out of a mixture that might have all of the minerals in it, let's take a very hot magma that's melts, and they can like flow around and be mixed, right? As it cools, different minerals within that mix but like solidify at different temperatures. So there's always the easy allegory with like igneous is it's like going from liquid water to solid water. You get it cold enough, right? You get liquid water cold enough, it turns to a solid. You get liquid magma cold enough, it turns to a solid. That's an igneous rock. Where that analogy breaks down, though, is water is just water, H2O. And its freezing point is 0 degrees C. So you go from past that line of 0 degrees C and it turns into a solid. Well, magma is a mixture of all kinds of different minerals, and all of those minerals have their own 0 degrees C. They have their own freezing points. So as a very hot one that might contain all of the minerals cools and cools and cools progressively, within that, different minerals at different points will solidify. Now, the nitty gritty on this might get a little confusing, and I won't go that way on quizzes because that's not the focus of this course, right? But the idea that that could be responsible for changing the composition of a magma as it progressively cools could come into play, because that's how we're going to end up with different kinds of magmas, right? Now, the biggest thing on this little note sheet is going to be this column right here. So make some sense out of this before you quit. The amount of silica that's in a magma is going to have the biggest effect on both how it behaves and what kind of volcano is a result of that. So when you get down here into the felsic, what we call felsic igneous rocks, when we get to that end of the spectrum, which yes contains these minerals and which you don't have to memorize, but what we'll want to know is that these are the ones that are higher in silica. So if like this little line graph doesn't make much sense to you, make a note for yourself over here, because without this, when I talk about it with volcano types, it'll be baffling. This is your higher. Sorry. Oh, do a subscript here. There we go. Whereas when you get down to the mafic end, that's your lower silica. And that's my goal today. That has implications in the next video we'll do, and then in the next couple of videos we'll do. But when you get down to this end, it's lower. And if, again, the reasons why will be apparent, right? So we got felsic rocks, we got mafic to ultramafic rocks, and the giant thing to get out of it today is that difference in silica. And if you're a note doing type, get to this end, and it's less. And that will make dramatically different behaving volcanoes, dramatically different size, dramatically different risk levels, and dramatically different like shapes and structures and everything. All right, sound good for today? That should do it for most of like the real basics on what we're going to get out of igneous rocks. And we'll be more detailed going forward when we move into the hazards book chapter out of this. Thanks, everybody. We'll talk to you soon.